Every folder you've ever opened, every menu you've ever clicked through, every organization chart you've ever seen, they all share the exact same underlying structure. It's called a tree, and it's about to become one of the most important concepts in this entire course. So far, everything you've learned, arrays, linked lists, stacks, queues, has been linear. One item leads to the next in a straight line. Trees break that pattern completely. They branch. Today we're covering what that actually means and why it matters. A tree starts with one node at the top called the root. That root connects to other nodes below it called children. Each of those children can have their own children too. Unlike a linked list where each node points to exactly one next node, a tree node can branch out to multiple children at once. Trees borrow family terminology, and it sticks because it's intuitive. A node's parent is the one directly above it. Its children are the ones directly below. Nodes with no children at all are called leaves. They're the end of the line. This vocabulary shows up constantly once you start working with trees. Your computer's file system is a tree in the most literal sense possible. The root is your main drive. Folders are nodes with children, other folders and files inside them. Files themselves are leaves. They don't contain anything further. That's why navigating folders always feels like moving up and down levels, because that's exactly what's happening. Trees are organized into levels. The root sits at level 0, its children at level 1, their children at level 2, and so on. The depth of a specific node is just how many levels down it sits from the root. This matters because depth directly affects how long it takes to reach a specific node. Beyond file systems, trees show up in HTML's document structure, in decision-making systems, in organizational charts, in how databases index data for fast lookups, in autocomplete systems, and in how your code's own syntax gets parsed and understood. Anything with a natural hierarchy, one thing containing other things, is almost always modeled as a tree. Here's what trips people up: assuming every branching structure is automatically a tree. It's not. Real trees follow a strict rule. Every node has exactly one parent except the root, which has none. If a node could have two parents, or if there's a cycle, a loop back to an earlier node, you're no longer looking at a tree, you're looking at something called a graph, which we'll cover later in this course. A tree starts with a root, branches into parent-child relationships, and ends at leaves with no children. It's organized into levels, and depth measures how far a node sits from the root. File systems, HTML documents, and databases all rely on this exact branching structure. This is video 15 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you catch the next branch of this series. Coming up, binary trees versus binary search trees, where we narrow trees down to one of the most important specific types you'll actually use.